Hi, this is Margo. This is Sunday evening, August the 6th, 2023. I hope everyone is safe and doing as well as possible. And I'd like to welcome everyone to the show tonight. This will be my weekly update that I'll be putting on YouTube, where we're going to go over climate things for the week, methane and sea ice and earthquakes and some other things. And we made it through another week. It just amazes me that, somehow we make it through another week. I'm getting a really late start tonight. I didn't intend to start this late, so it's going to be a late night, but that's okay. I'm ready. And I wanted to start out the show with just going over a blog post from Robin Westenra, and it has to do with the volcano, the underwater volcano that erupted near Tonga over a year and a half ago. It was in January of 2022. And about how much water vapor that released into the atmosphere, and that this is some scientists are thinking that this is triggering the extreme heat that we've got going on, especially in the southern hemisphere. Because it's winter down there, but it's not acting like winter. And that, so anyway, I just wanted to kind of go over this. And he so here's a picture, in case y'all don't remember it. This was a picture of the explosion, and it was in January of 2022. And this was a tweet from Robin Westenra, and he says, Hunga Tonga, Hunga, 10 times more greenhouse gas emission than humans, but where are the climate scientists? The largest and highest injection of water into the stratosphere since satellites began taking measurements, 160,900 tons, or 146 metric tons of additional water vapor. And that's the beginning of the tweet. And you can click here to go to it. We can do that. Additional water vapor had entered the stratosphere since the volcano erupted, reaching a maximum altitude of 33 miles, or 53 kilometers, which is in the mesosphere, the layer of the atmosphere that extends from the top of the stratosphere to an altitude of 53 miles, or 85 kilometers. And here's a picture of it. Yeah, it was quite the event. I was reporting on it. And that was it exploding. So let's move on. The Hunga Tonga volcanic eruption of January 2022 explains short-term global warming. The huge amount of water vapor hurled into the atmosphere as detected by NASA's microwave limb sounder could end up temporarily warming Earth's surface. And and then this guy, he goes on and says that water vapor is the real greenhouse gas because there's so much of that in the atmosphere, as opposed to the other greenhouse gases. But anyway, it's another perspective that I think we need to consider and take into account, and Sam Carana mentioned in one of his recent posts about the water vapor from the Tonga volcano is contributing to higher temperatures too. So and here's another article: record global temperatures driven by Hunga Tonga volcanic water vapor visualized. And this was I think this was from Live Science. The only thing that bothers me when I see articles like this where every word is capitalized, I mean, who writes like that? You know, I guess they're trying to make an emphatic message, but I just find it really hard to read. But anyway, readers may recall that we have reported on the massive amount of water vapor that has been injected into the stratosphere by the 2022 eruption of the Hunga Tonga volcano. A recent study said a 13% increase in stratospheric water mass and a 5-fold increase of stratospheric aerosol load. Water vapor is by far the strongest greenhouse gas, according to NASA, and it stands to reason that the dramatic increase in stratospheric water vapor is having an effect on global temperature. And Dr. Ryan Maui writes on Twitter, everything was going fine until mid-March 2023, and then a dramatic 1 degree C warming spike in a matter of 2 weeks raised global temperatures to the record levels we are at today. And La Nina to El Nino is certainly important for the equatorial Pacific temperature increase. But how is Hunga Tonga affecting the southern hemisphere polar vortex? Not so good with the Antarctic sea ice down there. And the northern hemisphere is much warmer than normal, especially in the Atlantic. How are all those trillions of gallons of water vapor in the stratosphere doing? How much is left? And how many more years of impacts? And then here's a graph he provided. With April and July, and this is temperature anomaly, 2-meter temperature anomaly. See how they're jumping up there for April and July. And another metric, the UAH satellite data also shows a spike in recent months, though still not as strong as the 2015-2016 El Nino. It is at least as strong as the 1997-1998 event. So there's that. from a recent publication, Global Perturbation of Stratospheric Water and Aerosol Burden by Hunga Tonga Eruption. Bold Mine. The eruption of the submarine Hunga Tonga volcano in January 2022 was associated with a powerful blast that injected volcanic material to altitudes up to 58 kilometers from a combination of various types of satellite and ground-based observations supported by transport modeling. We show evidence for an unprecedented increase in the global stratospheric water mass by 13% as compared to climatological levels, and a fivefold increase of stratospheric aerosol load, the highest in the last 3 decades. And here's some more charts, and you can see it's going straight up. Starting in 2022, and it's still high here in 2023. And so this is quite extensive. I'm not going to read every word. Here's another one. Tonga volcanic eruption may have role in fueling summer heat waves. Scientists have long sounded the alarm about the worsening climate crisis, warning that humans burning fossil fuels contributes to the warming planet. But as Eric Sorensen explains, there's evidence Tonga's massive volcanic eruption in 2022 was playing a role in the summer's heat. Tonga's eruption injected so much water into Earth's atmosphere that it could weaken the ozone layer. We're seeing that. And that it could, the atmospheric water vapor could also contribute to global warming. When an underwater volcano in Tonga erupted in January, it belched out more than ash and volcanic gases. It also spewed 58,000 Olympic-sized swimming pools worth of water vapor into Earth's atmosphere. This water vapor could end up being the most destructive part of the volcano's eruption because it could potentially exacerbate global warming and deplete the ozone layer, according to this study. When the Hunga Tonga Haipa volcano erupted on January 15th, it became the most powerful explosion on Earth in more than 30 years, with an equivalent force of 100 Hiroshima bombs. The explosion sent shockwaves around the planet, causing the atmosphere to ring like a bell, I remember that, and generating tsunamis that battered nearby coasts. A plume of ash and dust reached higher into the atmosphere than any other eruption on record, and triggered more than 590,000 lightning strikes in 3 days. In the new study, researchers used data collected by NASA's ARA satellite to assess the amount of water that was thrust into the stratosphere, the second layer in Earth's atmosphere, which extends from 4 to 12 miles. Or 6 to 20 kilometers up to 31 miles, or 50 kilometers above the planet's surface. The results revealed that 160,900 tons, or 146,000 metric tons, of additional water vapor had entered the stratosphere since the volcano erupted, reaching a maximum altitude of 33 miles or 53 kilometers, which is in the mesosphere. Okay, that's as a repeat of above. We estimate that the excess water vapor is equivalent to around 10% of the amount of water vapor typically residing in the stratosphere, which is the biggest increase scientists have ever seen, researchers wrote in the new paper published online July 1st in the journal Geophysical Research Letters. The water vapor may remain in the stratosphere for around half a decade. It is not totally surprising that the Tonga eruption injected a large amount of water vapor into the atmosphere, considering the explosion ignited around 492 feet or 150 meters below the ocean surface, the researcher said. When the volcano erupted, seawater that came into contact with the erupting magma was rapidly superheated, which resulted in large amounts of explosive steam. This is one of the main reasons the explosion was so powerful. However, this is the first time the amount of water has been accurately measured, and it turned out to be much more than scientists had expected. Isn't that always the story? It's always much more, or much worse, or much faster than expected. The Tonga eruption launched 58,000 Olympic swimming pools worth of water into the stratosphere. Normally, big volcanic eruptions release large amounts of ash and gases such as sulfur dioxide, which can create reflective compounds in the atmosphere. And as I recall, it did release a lot of sulfur dioxide, and that cloud drifted mainly to the west and covered a lot of the Indian Ocean. Went across Australia too. These volcanic byproducts can block sunlight from reaching the planet's surface, which can cool the atmosphere. However, the Tonga eruption produced surprisingly low levels of sulfur dioxide compared with similarly sized explosions, and most of the ash it ejected quickly fell to the ground. Well, there was still a lot of sulfur dioxide. As a result, experts initially estimated that the underwater explosion would have minimal effects on Earth's climate. But these estimates were based on the amount of ash and gases that the volcano emitted and did not account for all the excess water vapor, which could be just as problematic. The excess water, the researchers warned, could have a radiating effect that could warm the atmosphere much as greenhouse gases do, because the water is likely to stick around longer than other volcanic gases like sulfur dioxide, which normally fall out of the atmosphere within 2 to 3 years. The water's warming effect will likely outlast any cooling effects the gases create. This means the Tonga explosion will likely be the first eruption on record to cause a warming effect rather than a cooling effect on the planet The researchers also pointed out that such a sharp increase in water vapor could decrease the amount of ozone in the atmosphere, thus potentially weakening the ozone layer that protects life on Earth from damaging ultraviolet radiation from the sun. Stratospheric water, or H2O, can break down into OH ions over time. Those ions could react with ozone, which is made of 3 oxygen atoms, to create water and oxygen. However, it is unclear how this will affect the ozone layer as a whole. However, the researchers also think the increased water vapor could decrease the amount of methane in the atmosphere, which is one of the main greenhouse gases responsible for climate change. The same OH ions that react with ozone can also react with methane to produce water and a methyl radical, methane with one less hydrogen atom, which traps much less heat in the atmosphere than methane. Hopefully, this potential reduction in methane might offset some of the warming caused by the water vapor. Well, we haven't seen that yet, but it could explain why we got a slow start to the warming season this year with methane. However, the study authors think it's still too early to predict the exact climate effects of the Tonga eruption. It is critical to continue monitoring volcanic gases from this eruption and future ones to better quantify the verifying roles in climate, the researchers wrote. This was originally published in Life Science. So, I wanted to bring this to everyone's attention, and so we need to remember all of this. This is another thing to factor in. You know, it doesn't rule out other things, but it is another thing to factor in, and you know, it's a wild card, and we're really living in uncharted territory, and I've been saying this for, I don't know, ever since I really started doing this. I started doing my reporting, just exploring the different things in April of 2018. And then in 2019 was when I started doing the daily, you know, tracking the CAMS methane daily, and then the NOAA methane and everything. And so that's when I got real serious about it. And so I've been seeing in my research that you know, we are in uncharted territory. And so what does this mean? Well, it means a warmer Earth. And Sam Carana has talked about water vapor being a big heater for the greenhouse gas, and a big cause of heating. And so this was unexpected, and so it's speeding things up, is what I'm trying to say. And so what they might have thought, you know, was going to happen by 2030, maybe it's going to happen by 2024, 2025. etc. We just don't know. We don't know. And then we've got all the other things, you know, El Nino now, and the sunspots, and extra radiation coming in from the sun, and the ozone layer kind of, it's not looking good, and so we've got huge problems. And so I'm glad that y'all are here with me on this journey. And it's you know, the group that watch my videos and follow my work, and also the ones over on Subscribestar, which is a very small number, but that's the platform that I use to post everything that I find daily. And if you'd like to support my work, it's only $5 a month. You can come on over to Subscribestar, and you know, it's a small community, but you know, I post everything over there, and then I archive it on my website so that we have a record of everything going back, like breadcrumbs for, I'm thinking it's going to be for people in the future who want to see how things fell apart. I'm archiving the collapse. And so I'd like to thank y'all for being here. It's an eclectic group. You know, you've got to have a passion about all of this to be here. And this is what, you know, what I'm focusing on these days. This is my big thing that I'm focusing on. So now let's get into our report for tonight. And so we're on Climate Reanalyzer. This is for today, Sunday, August the 6th, 2023. And we're starting on 2 meter maximum temperatures around the planet. We're seeing some cooler temperatures over the Arctic basin. The aqua is freezing, and then the dark aqua is a little bit cooler, and then we've got greens all around it. That's above freezing. It's still warm temperatures going up through Canada, up through Alaska. Here in the U.S., we've still got a lot of whites coming across from California all the way across through Texas and the deep south, and they've had some awful heat indexes and reaching wet bulb temperatures that are very dangerous because of the humidity and the high heat down here in the south. Hold on. Got to get my setup here. Okay. And where you have the high temperatures and the high humidity, it's really deadly. And you know, they've warned about that. The wet bulb temperature, and Sam Carana did a recent post about that. I recommend that. Anyway, let's move on down. Here's the flat view, and see, we've got whites throughout the interior of South America. whites moving into the dark grays across northern Africa. The grays are 50. It's almost solid gray when it's 50 degrees C, and that's, I forget what that is, like 123 degrees Fahrenheit, something like that. But I think they're going to have to raise their chart. I think, I mean, you know, we've already seen higher temperatures than that, like at Death Valley and places around the Middle East, Saudi Arabia especially. So anyways, see all these whites coming up and around, and so the white is 40 C or higher, or 104 degrees Fahrenheit or higher, and so you're getting into really hot, and it's every day. I mean, there's no break, and it's unlivable when it's like that. I mean, it takes a toll on everything and everyone. Okay, here's 2 meter temperature anomaly, and see, we've got a little bit of blue over this Arctic basin where it's a little colder than normal, but then it's brown here by Alaska, Canada, and then coming down through western Canada. We've also got brown on this east side, just east of the sea ice there, coming across through Russia. We've got dark browns, Russia, coming into western Russia. And then we've got blues right next to the browns coming around, and then browns in the south here in the U.S. Here's the flat view, and look at, see, Russia's really heating up here, and we've got huge methane releases throughout this area too. Europe is in the blues right now. South America is all brown except for the tippy point. Australia, you're all brown. So here's our global overview. Worldwide, we're up 0.8 C, higher than normal. The northern hemisphere is up 1.09 C. The Arctic is up 1.52 C. The Antarctic is down 0.7 C. The southern hemisphere is up 0.52 C. And the tropics are at 0.87 C. And we've been seeing this anomaly at the tropics for the last few weeks, where it's gone way up. It used to be more even with the southern hemisphere, but it's gone way up. And so that can be attributed to that increased water vapor. Here's precipitation in clouds, and the green is rain, the blue is snow, and the purple is rain-snow mix. And so we've got a couple of systems coming across the Arctic region here, right across the sea ice. So it's raining here, just north of the Canadian archipelago and Ellesmere Island, so it's raining on what's left of the thicker sea ice, and we've got snow right next to it, and rain-snow mix. And then just to the east of the North Pole, it's a long straight line of rain-snow mix and rain coming from Siberia all the way across through the Fram Strait. And we've got, looks like some rain and snow here in the North Baffin Bay and on Greenland there. And here's the flat view. And with the increased water vapor, you see more intense storms. There's more water to come down in the storms, and so you see the rain. And like last winter, I mean, here in the Reno area, I mean, well, and of course California was having those just massive rainstorms, and here in the Reno area too. It went all winter long, and now I'm thinking that could have been from the combo plate, but a lot of it from the extra water vapor. Okay, so here are the jet pieces, and what's left of the jet stream as it's breaking up and mutating. The mutant jet stream. Let's see, it's gone rogue. There's no rhyme or reason, it's just gone rogue. We'll look at snow cover, sea ice in a minute. And here's sea surface temperature anomaly, and we've been setting records here. And as I showed in my show last week, they increased the they're measuring here up to 9C higher than normal and 9C lower than normal. So they added 6 degrees to their chart there. And so here we've got browns in the North Atlantic coming into the Barents Sea. We've got reds and pinks here next to the Russia coastline. Pinks here in the Kara Sea. And looks like that's moving into the white, so that's up into 9C higher than normal. And then anywhere it's already melted, the ice is melted. See, it's already going into the reds and the browns. And look at this around the coast of Alaska and Canada. That's up in the whites. In Hudson Bay, you've got reds now. You're heating up. Look at the Great Lakes, they're in the browns now. And then this area in the North Atlantic, I keep calling this the evil blob or evil eye. See, the reds are moving up closer and up coming up towards the Baffin Bay and up towards Greenland. Then there's this area just off the coast of North America. It's a long oblong area. Normally we see like a circle, but this is like a big long oblong evil blob here, moving into the reds and the browns here. So the dark brown is 3 to 4 C higher than normal, moving into the reds. The bright red is about 5 C higher, and so these oceans just keep heating. They're just they're absorbing as much heat as they can. And you can see, like here in the upper mid-Atlantic or northern mid-Atlantic, see the dark brown that had been lighter brown. There's the Gulf of Mexico. Here's the flat view. And let's see, here's the Atlantic. Here's a little bit of blue next to Africa, but it's all brown. Then in the Pacific, the equatorial Pacific, this is as a result of El Nino. See how this is heating up all the way across. And so here's our evil blob down here next to the coast of Peru and Ecuador. That's all brown around Central America, Mexico. Then we've got a little bit of blue, a little break here where it comes up towards northern Baja in California, and then it's brown. And then we've got another humongous long evil eye in the upper mid-Pacific, northern mid-Pacific here, just south of the Aleutian Islands. And then it's red around Japan too. And here in the Indian Ocean, there's a lot of browns too. So, Mediterranean, there's all the browns. See the Black Sea, that's all brown. All these interior bodies of water are turning brown. So there's that. Now we'll move on to methane. And we're starting with the NOAA methane data for yesterday, the 5th. Looking at the MET-OP-B satellite in the morning for the 1,000 millibar level. The mean was 1,846 parts per billion. And in the afternoon, the mean was 1847. And there's quite a bit of missing data here, but I'm going to count it because we've got a lot of data that's not missing anyway as well. Okay, so the MET-OP-C in the morning, the mean was 1849. And in the afternoon, the mean was 1847. Had quite a bit of missing data too. And these are areas that have high methane. So I'm counting all of those. And then on the 487 millibar level, for the MET-OP-B in the morning, the mean was 1923. And in the afternoon, the mean was 1927. On the Met-Op-C in the morning, again with the missing data, the mean was 1896. I think that's the highest we've had in this model that we're doing. No, I'm mistaken. Okay, so 1896, so I'm counting that. And then in the afternoon, the mean was 1897. So, let's look at our charts. So this is for the Met-Op-C satellite only, for the 487 millibar. Remember, if you've been following my channel, why I broke it out like this, because there was a lot of missing data on the Met-Op-B satellite for a while there, and so I broke it out so that we would have something to compare to that would be consistent. So the fifth averaged out to be 1896.50. That gives us an increase this week of 4 parts per billion. So they're shooting up. And that's our biggest increase in a week so far this year. Now we've seen it go down that much, but yeah, see, it's going up steadily. So let's see what happened here this week. So we ended last week at 1892.50, and we'd only gone up 0.5 that week. And then the 30th, we went up 1.5. On the 31st, we went down 1.0. On the 1st, we went up 1.5. The 2nd, we went up 1.0. On the 3rd, we went up 1.5. On the 4th, up 1.5. Down. Okay, sorry. 3rd and 4th, we went down 1.5 each day. Then the 5th, up. That was a sharp increase of 4.0 in one day, giving us, and see, it was just stair-stepping back and forth all week, and so that gave us the increase of 4.0 for this week. And then for the all 4 readings on the 487 millibar, the average was 1910.75, giving us an increase of 2.0 this week. And then on the 1000 millibar level, which equates to surface level, for the 5th, that averaged out to be 1847.25, and so that was a decrease of 5.0 there. So there's that. Now we'll look at the CAMS methane data. This is Copernicus Atmosphere Monitoring Services out of the EU methane forecasts. And our base time and valid time are both for Saturday, August the 5th. Arctic area and surface level is where we're starting. And the data is for Saturday, and the forecast period runs Sunday, Monday, Tuesday, Wednesday. And so what we've been seeing this week is this hemorrhaging going on at CAMS NOAA. It's pretty much all week, and also at this spot just next to it in the North Care Sea. And you can see it's spreading out. You know, it goes up and then spreads out across the Arctic Ocean. Also, here in the Scandinavian area, over to Russia, this has been just filled up, a big black blob, and releasing over in the ocean high methane, see, and streaming out. So we've had a big increase in methane here, and see how it's streaming, high readings streaming up, or the Barents Sea, Kara Sea. Also here in the Laptev Sea. And so the interior is higher as well. Our background colors are higher. It's see, when it pulses down, that's at nighttime, where it cools off, and so it goes down. But it still doesn't go down completely. It's still got some reds even when it pulses down. And then here's Alaska. They've got high methane in the interior because of they've got a lot of permafrost and you know, a lot of snow melting and things like that. And then here's Canada. This is where the majority of the fires are burning up here. And it's also where the tar sands are. And so I don't know if that'll ever go out with that burning. Here's North Dakota. And then here in the U.S., see this upper Midwest. It's pretty blobby. And then all the way across. So there's that. And then go to the North Pole view. So here's the UK and Ireland, they're filled up. Germany, you've got some high readings. Also southern France. Here's the Persian Gulf in India. Here's China. And China's had horrific rains, and a lot of flooding. They've had horrific rains this week. So that could be from the increased water vapor. I mean, that could explain a lot. And I'm not discounting the other factors either. It's just another one for us to think about. Okay, here's the global view. And we can see that our main background color now in the southern hemisphere is up to this lighter blue, which is 1860 parts per billion here on the chart. This one and so the 1840 is being squeezed out as methane's going up. See, it's coming all the way across the Antarctic. And then 500 HPA. So look at how the dark areas have redistributed here. We've got reds further south and yellows further south. See, yellows even coming down over the Antarctic. So it's redistributing as the season goes on. And here's total column, and it's look at this one long line, and look at the wide band. And this is methane added up through all the layers of the atmosphere, giving us the highest readings. And so it's from Africa all the way across to China and out. Here's a line coming up past Hokkaido, Japan. Then all the reds. So there's that. And then a couple more things that I track on CAMS. Here's sulfur dioxide for today. And we've got the highest readings up here in Alaska, and let's see, let's go back. Yeah, East Siberia and Alaska is where we have the highest readings. Let's see. This is at 500 HPA. Then we have some little spots like down here in the Indian Ocean and down here just east of Australia, and here in the South Pacific. I'm thinking this is from plate movement. And here's the North Pole view, so we can get a better image of, let's see here, this is Russia. Now Kamchatka's down here, so I'm not sure what this is from. And then here Alaska. Pretty blobby. I mean, it almost looks volcanic, but I don't know that there are volcanoes up there. I don't know. This is at 500 HPA, so whatever it is, it shot up in the atmosphere or is falling down and holding at that level. I don't know. It's a mystery to me. And here's the Antarctic ozone, and we've been watching these danger zone holes morphing, opening and moving around the continent this week. At one point it had gone down to the next level down, and when you see it in this kind of purplish blue and the thick black line around it, this is in the danger zone, and this is between 200 and 220 Dobson units. Then it goes down from there too, and then the next color up is the aqua. And so in the winter time here in the Antarctic, this hole opens up, and the ozone hole, it's gonna be there. You'll see articles saying that it's been healed and it's closed up, and no, it hasn't. We can see it right here. Here's the Arctic ozone. And we can see the green. Any shade of green is thin. It's below what's considered a good reading. The solid yellow is 300 Dobson units, and that's considered average or a good reading or higher. But see here, we've gone in from the chartreuse into the green here. This is Franz Josef Land. This green area. This is where we saw the huge methane coming up. So methane will also cause the ozone layer to be thin, and then it's thin over this Beaufort Sea too. And there's smoke. There's a lot of smoke coming up from the wildfires, and that will also eat away at the ozone layer. So here's the global view for ozone, and you can see it's green all around the middle of the planet. So yeah, this is not good. And here's the smoke for today, and here's the Canadian wildfire smoke, and let's see, it's going up You can see it all the way to the Arctic Ocean there, and into Alaska, and the smoke is still, it had lifted a little bit over the U.S., but it's coming back down now. And here's from the Congo region of Africa, and here's where the fires are burning in Russia. I know they're important, but I mean, they're just dwarfed by the fires that we see in Canada. Okay, that's all. Now, we'll move on to the sea ice portion. I may take a little break a little bit later, but I've kind of got my burst of energy, so I want to do this as, just try and plow through. So we're going to start with our slideshow from Climate Reanalyzer. And this is sea ice and snow cover for today. And we can see the Hudson Bay is open, Baffin Bay is open, these tributaries and this Northwest Passage area. It's a lot of open water there. This Beaufort Sea is all but collapsed. There's just a little area kind of hanging on here next to this island, but here's the Chukchi Sea, so this is in a state of collapse right now. And this little bridge that had been reaching across to Siberia, that's collapsing, and this whole Laptev Sea area is going down, and we've got high melt on this east side now. Well, you saw the rain, you saw the freezing rain coming straight across, and here and here, and so we'll see the effects of that. I mean, that'll melt the snow. The ice, faster than anything, is rain, or even freezing rain, because it means it's warm enough. Rain-snow mix, it means it's warm enough to not be completely freezing. Rain-snow mix. So let's see what happened this week. Here we were last Sunday, and so let's go back, see how much it's opened up. So here's last Sunday, the 30th. Here's Monday, big change there, look at that. Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. And then the U.S. Navy is sporadic about updating. They're updating a couple of times a week, if we're lucky, which I'm grateful that they're updating, when they are, but seeing as we're in high melt with this Arctic sea ice, I sure would like to see it every day. But we'll take what we can get. So they updated it. The latest information is for the 3rd, August the 3rd, which was Thursday. And here's our chart on the right. The bright aqua is 2 to 2.5 meters thick. So let's zoom in. And see, this is really diminishing, and it's exiting through the nearest strait, also through this Fram Strait, and through these tributaries here. And you can see the bright aqua is becoming less and less as it's thinning down into darker aqua and then blue and purple. And the dark blue is about 1.25 meters thick. The dark purple is about 1 meter thick. And then the light lavender is about 0.5 meter thick, and then it goes down to nothing. And where you see like this light lavender, it's very little ice. I mean, it's just a little coating, and it's probably pretty mushy, and there could be a lot of open water. And so, but they count that as extent, because any little film of ice will reflect something rather than absorb all the heat directly without ice. But you know, it melts faster too, so what we're seeing is really this whole area is in a state of, I'm calling it a state of collapse. We're also, just recently, we're seeing a big melting on this east side too. A little bit of green, that's about 3 meters thick, and just a touch of bright red, which is about 4 meters thick. So our majority of the thicker ice is just above this Canadian archipelago, like an arc, a little arc coming across Greenland. Okay, and here's the 30-day animation, and this forecast goes out to the 11th, so 5 days away. So let's see what they're forecasting. You know, this is nail biting time. Now what happens is, usually the ice is in high melt through July, in July and the first part of August, and then it starts slowing down. It's still melting, but the rate of melt becomes slower, and then it usually reaches minimum around mid-September to September 19th or so. And then it starts refreezing. But considering all of our factors, including El Nino and July being the hottest month on record, and the increased water vapor, and all of these things, you know, we could continue to see high melt. And, you know, it might not slow down in a week or so. It might keep going, might keep melting really fast. We just don't know. And considering the temperatures of the ocean water, you know, next to the ice, and then it's warm water coming up underneath, and so it's melting from underneath too, so it's a whole combo plate. So I'll stop it at the end. Here we are at the end of the model on the 11th. And they're showing, see these white spots? These are, wherever you see a whitish area, that is open water. Here's the North Pole. And so, I mean, this looks better than it really is, I think. And let's look at something. I'm just wanting to look at this aqua area, how it changes. So let's click through and watch this aqua area. See, it's kind of flattening out, and you can see the ice moving down in this Fram Strait. One more. Okay. So it's even like coming in, curving inward here, and so our bright aqua is just following the coastline basically of Greenland and mainly Ellesmere Island. So there's that. Here's the Beaufort sea ice thickness. This was updated to the 3rd. Like I said, any of these white spots, that is open water. So we've got open water mixed in with these tiny bit thicker areas, but not much thicker. And here's the 30-day animation, and this forecast goes out not that far, only to the 8th. So you see what I'm saying? They're sporadic about what they're updating. maybe they're low on personnel. I could do it for him. But anyway, no one's asked me to, but I could do it. So you can see a big change in this as it's moving through the movie down into all those whites. Okay, what am I doing? Okay, I didn't record Arctic data. There was no new Arctic data this week. I mean Antarctic data. See, I'm getting tired. No new Antarctic data for the week. Okay, this is National Snow and Ice Data Center. Arctic sea ice concentration for yesterday. And so the darker the blue it is, the more it's already melted and is falling apart. Very little white areas left, which are intact. And see, even down here along this Canadian coastline, this is where we've got the thicker ice. See, that's got blue, so that's melting. All around the North Pole here it's melting. Looks like we've got a hole opening up just southwest of the North Pole, and this whole east side is in high melt. And here's sea ice extent for the melt. This is for yesterday. Now see, it had angled up a little bit for a day or two as the melting had slowed down, but now it's angled back down. And we're just above 2012 and we're below the median. Here's the Antarctic. And here's their refreeze. It's not looking good. It looks like it's stalling out. We've got a couple of days where that line is kind of creeping down. And it's well below last year. See? And last year was record low, so we're at record low again. And I had a viewer email me the link to the University of Bremen website for the Arctic sea ice thickness, and I'd like to thank him very much for this. I never would have found this page, and I'll leave a link in the description below for I'll put it in show links, and they update this every day, and this measures the thinner ice in quite a bit of detail, is what I figured out. And anyway, I'll be tracking this now, and it's measured in centimeters, so don't pass out by seeing that, measuring in centimeters. And this peach color is this chart will only goes to, you can't really see it, 50 centimeters, and so anything above that is in the peach area. And so that includes our 2 meter sea ice that we saw on the Navy website and so forth. And so this is what I'm saying, like this emerald green is from 0 up to maybe 2 or 3 not kilometers, centimeters. So like I'm saying, is just barely there. It's like just a film over the ice. And a centimeter is equivalent to about 1/4 of an inch. Just under 1/4 of an inch. So this is quite thin. So where you see the blues and the aquas, that's going down. There's 10 centimeters. So the aqua is 10 centimeters. The green is about 20 centimeters. The yellow is about 26 centimeters. The red is about 35 centimeters, like here. So this is not looking good. Okay, and on to Greenland. Here's our melting for yesterday. See, it's gone way down, but it's still melting in key areas like this southwest area and this northern part, and some more around the coast. Here are the cumulative melt days for this year, and the white is getting less all the time, and that's where it hasn't melted at all this year. And we can see cumulatively it's moving from the kind of gold into the reddish zone, 60 to 70 melt days. And here's the extent chart, and big difference from last week. See, it's dropped way down, and it had met up with the median yesterday, the day before, and then here it spiked up, and we're about at 12% melt right now. So there's that. So I've got to take a break before I can do NASA Worldview, so don't go anywhere. I'll be back, but we'll go ahead and get this picture up. Okay, I'm back. I thought for a minute there, I thought the first part had not recorded, so I was all in a panic, but I'd found out that it did record, and so I will go ahead and finish up the show for tonight. And it's just taken a super long time for me to get through this, and anyway, it's after midnight now, so thanks for hanging in there. So now we'll look at NASA Worldview, and here we are on the Arctic view, and here's the smoke coming up from Canada, and here are these systems coming across the Arctic basin, and now I'll show you. This is sea ice concentration right now. We can see all the areas where it's fallen apart. Let's go to blue marble view. There we go. That's a little easier to see. So you can see the Beaufort Sea is almost all melted out. a little bit thicker around the coastline here, but this whole west side is in collapse, and the north side is in collapse now. And here on the east side, see the yellow, that's where it's been raining, and the rain snow mix, and so that's in collapse as well. So let's go back to last Sunday, which was June 30th. So here we were last Sunday. So let's see what's happened this week. And just seeing some big changes day to day. So here it was yesterday, the 5th, and here it is today. So this west side has really cleared out a lot. And now I'll turn those layers off, and we'll see what we can see just from the satellite view. And I like to start down here in this Lincoln Sea area, and we've got clouds here, so we can't really see the Lincoln Sea. It's hard to see much of anything there, but in the nearest strait, you can see it's broken up, and see it through the cloud there, and it's flowing down. So this is the ice exiting through the nearest strait from the Lincoln Sea out into the Baffin Bay. And on the east side is our hole, and like I said, this is the storm, so can't see a lot right there. Here's Novaya Zemlya. You can see all of this is melted. There's no ice here in the Kara Sea, Gulf of Ob, Barents Sea. There's no ice there. Here's a little ice coming out around Franz Josef Land, and a little bit left in the North Kara Sea. Now I wanted to show, here's Severnaya Zemlya. Komsomolets is right down here. This is the area where it's been really billowing and hemorrhaging this week. And here's the Vovolov ice cap, and you can see the flow. It's pouring into the ocean, and here's where the ice had flowed out, and see it's all broken up now. But here's the flow. It's a constant flow. So there's that. And then this is open. This is the Laptev Sea. Here's the Russia coastline. Oh, I wanted to show something else. I forgot. Over here in the Barents Sea, you can't really see it today because the clouds. But yesterday, this is a really excellent view. You see all this green. This is algal blooms in the Arctic Ocean, and that's not good. That is definitely not good. And here's another view. Once the clouds move out of the way, you can see it's a huge area. It goes all the way up to the Russia coastline and out down here. Here's a good view. See, Look at that. There's a cloud over it. And it's covered up today. Okay, back up to the Laptev Sea. Right in here, that's open. It's open around the coastline here. Let's see, this is open. You can see through the clouds. There's no ice up here. Here's the ice edge. Then here, and here's this northern part that's collapsing, and that's well inside the 80-degree north latitude line. That's right here. And here's this storm. Well, okay, here it is today. This is a good view. Let's see. Look at this. So that's coming apart. And this east side, it's kind of hard to see right now. Let's go back up. So here's the East Siberian Sea, and this is Russia up here, and this is mostly open. I mean, it's so cloudy you can't tell. These are clouds. And then you can see the sea ice here through the clouds, but look how broken up it is. Lots and lots of open water. Let's see, and here it is coming down. And then coming on around. So here's Siberia, and see, this is open. Here's some of that like wispy sea ice I was talking about. Let's see, here's this whole west side falling apart, and so when you see the light lavender on the Navy website, this is it. So it's kind of misleading because, you know, it's just hard to depict with models where the open water is. It's just really difficult. Because you've got so much, you know, you've got wispy stuff mixed in there, and they count everything for extent. Here's the Bering Strait that's open. Here's Barrow, Alaska, and here's the Beaufort Sea. See, this is all open here, and here's the edge. Look at this. Yeah, that's in a state of high melt. Look at this. See how it's coming apart. And here's the smoke coming up from Canada. Here's the Amundsen Gulf. That's all open. And let's see, this is open here. So where the 2 to 2.5 meter thick ice. It's in a little dome shape just above, starting at this island of Canada, going across Greenland to this east side. Is just right in here of the thicker ice, and this other ice is thinning way down. Just can't see it now because of the clouds. It's kind of see, here's a hole. See that? It's breaking up. So that may be about all we can see here tonight. I missed the nighttime layer. That was good for lots of things. And as far as the Antarctic goes, without that nighttime layer, we can't really see a lot. And we can look at this layer, sea ice concentration. And there it is. So that matches up with the other models that we saw. So let's look at some earthquakes now. Right now there are 179 worldwide. There was one up here at Iceland of 4.6. This came in on the 6th at 7:26 in the morning, and got kind of some clustering here in Afghanistan, 5.2 there right now. Here, Indonesia, 5.3. Anyway, let's see what's going on. So we've got a couple, well, this one on the fulcrum point of the Juan de Fuca plate, so that's right on the San Andreas fault line, 2.5. So, there's one in northern New Mexico, 3.8. Let's see. Not seeing any huge ones. So, let's turn on 7 days, all magnitudes. So this week we had 1,927 earthquakes total. And here was one in the Baffin Bay of 4.3 at Davis Strait. That one came in on the 1st, and we had Northern Mid-Atlantic Ridge 4.5, and also 5.3 here. And you can see all the dots there. Here, 5.7 off the coast of Kamchatka, And here, around this Antarctic plate line, so this is plate movement, 5.4 South Sandwich Islands, 5.2 Pacific Antarctic Ridge, and 5.2 Australia. We had, look at all this activity around the Cocos Plate. See, look at all of this, even up at the top. And that's a 5.9 near Panama. And then here on the Juan de Fuca Plate, we had action on this west side. 4.0 was the largest. And then see, clustering on this fulcrum point. There's a lot of pressure there. And you can see, I mean, this is the main drag for earthquakes. California and Nevada border, the main location for earthquakes. So that's my report for tonight, and I'd like to finish up by reading. Now last week we finished up the book of Job and saw that he got rewarded. God rewarded him for staying true, and even though he went through a lot of trials and a lot of persecution from Satan, he never turned his back on God, so he was rewarded for that. And I think what I'm going to do is, right now I'm continuing to read out of the Old Testament on my Vimeo videos, and so I'm going to continue that and finish up the Old Testament over there. And there are quite a few books of the Bible that did not make it into the Bible, but that were considered, and they're considered part of the Apocrypha. And so I think I'd like to make my way through those books and see what we can learn here. So the first one, I'll show you here, like Malachi is the last book in the Old Testament, and then Matthew is the first book in the New Testament. So we have all of these in between. Now I've done this one, Wisdom of Solomon. I've done that whole one, but I haven't done any of these others. So we're going to start with Tobit. The Book of Tobit, Chapter 1. The Book of the Words of Tobit, son of Tobiel, the son of Ananiel, the son of Aduel, the son of Gabael, and the seed of Azael, of the tribe of Naphtali, who in the time of Enemesor, king of the Assyrians, was led captive out of Thisbe, which is at the right hand of that city, which is called properly Naphtali, in Galilee above Aser. I, Tobit, have walked all the days of my life in the ways of truth and justice, and I did many alms deeds to my brethren and my nation, who came with me to Nineveh, into the land of the Assyrians. And when I was in mine own country, in the land of Israel, being but young, all the tribe of Naphtali, my father, fell from the house of Jerusalem, which was chosen out of all the tribes of Israel, that all the tribes should sacrifice there, where the temple of the habitation of the Most High was consecrated and built for all ages. Now all the tribes which together revolted, and the house of my father Naphtali sacrificed unto the heifer Baal, and I alone went off into Jerusalem at the feasts, as it was ordained unto all the people of Israel by an everlasting decree, having the first fruits and tenths of increase, with that which was first shorn. And then gave I at the altar to the priests, the children of Aaron. The first 10th part of all increase I gave to the sons of Aaron, who ministered at Jerusalem. Another 10th part I sold away, and went and spent it every year in Jerusalem. And the third I gave unto them to whom it was meet, as Deborah my father's mother had commanded me, because I was left an orphan by my father. Furthermore, when I was come to the age of a man, I married Anna of mine own kindred, and of her I begat Tobias. And when we were carried away captives to Nineveh, all my brethren and those that were of my kindred did eat of the bread of the Gentiles. But I kept myself from eating, because I remembered God with all my heart. And the Most High gave me grace and favor before Enemessar, so that I was his purveyor. And I went into Media, and left in trust with Gabael, the brother of Gabrius, at Rages, a city of Media, 10 talents of silver. Now when Enemessar was dead, Sennacherib his son reigned in his stead, whose estate was troubled, that I could not go into Media. And in the time of Enemessar I gave many alms to my brethren, and gave my bread to the hungry, and my clothes to the naked. And if I saw any of my nation dead, or cast about the walls of Nineveh, I buried him. And if the king Sennacherib had slain any, when he was come and fled from Judea, I buried them privily, for in his wrath he killed many, but the bodies were not found, when they were sought for of the king. And when one of the Ninevites went and complained of me to the king, that I buried them and hid myself, understanding that I was sought for to be put to death, I withdrew myself for fear. Then all my goods were forcibly taken away, neither was there anything left me, beside my wife Anna and my son Tobias. And there passed not 55 days before 2 of his sons killed him, and they fled into the mountains of Ararat. And Sarchedonus his son reigned in his stead, who appointed over his father's accounts and over all his affairs Achiacharis, my brother Anael's son. And Achiacharis entreating for me, I returned to Nineveh. Now Achiacharis was cupbearer, and keeper of the signet, and steward, and overseer of the accounts, and Sarchedonus appointed him next unto him, and he was my brother's son. Tobit chapter 1. So I think it'll be interesting to follow the people, see the side stories, and we'll probably gain more clarification around the Old Testament as well. So I love you all, and I'm praying for you. If you haven't given your life to Jesus Christ, I recommend it before it's too late. And I hope everyone has as good a week as possible. And Lord willing, I'll be back here next Sunday for another climate roundup for all of y'all. So until next time, God bless you. Go in peace, and I will talk to you soon. Good night.